Good afternoon, ma'am.
Good afternoon.
Okay, let's start the session. This is week six.
Microelectronics Device to Circuits session. I'm Arpita Biswas from IT Jodhpur, a PhD scholar in Electrical Engineering Department. So let's start the session. This is more details about me, and this is the question number one. Is my screen visible? Hello.
Ma'am. Yes, ma'am.
So this is the question number one. A sinusoidal signal with a period of 1 second has a peak of 2.5 volt at 0.25 second and minus 25 volt at 0.75 second. This signal is applied at the input of a common drain amplifier. Find out the output value at time instant equal to the 2 second.
Ma'am,
Yes.
hello. Ma'am,
Hello.
the answer is the first option, ma'am, 0 volt.
Yes, 0 volt. Good. Can you a little bit explain about it? Why it is zero? Hello.
Yes, ma'am, yes, ma'am.
Try to explain it.
Ma'am, the formula is Vn is equal to A sin omega t plus 5, ma'am. We have to use that formula and we have to derive the uh, particulars of the information that then we can get the answer of it.
Okay. So see, since the time period of a input signal is 1 second, okay. So therefore the value of the input at time instant equal to 1 second will be zero. So as the signal is passed through a common drain amplifier or source follower, the output will be same as the input value. Okay. So input and output will be same. It is 0 volt. So this is the question number two. For fast operation of MOSFET circuit, the MOSFET requires lower GM, higher GM, or does not depends on GM or none of the above.
Ma'am, the option is B, ma'am.
Yes. Can you little bit explain?
Sure, ma'am, sure.
Yes, the right option is higher GM. So can we move forward the question number three? Actually, I have taken 30 and almost, I think, yes, almost there are so many numericals. Can I move forward the question number three? In the MOSFET small signal model, the overlap capacitance is due to first option is the channel charge, second is the gate electrode overlapping source drain diffusion region, and option C the junction depletion charge, and option D is the mobility degradations.
Ma'am, second option, ma'am, gate electrode overlapping source drain
Overlapping
diffusion.
source drain diffusion region. Good. Option B. This is the question number four. Find the value for the small signal output resistance V output for the amplifier shown below. Let the DC current through the M1 and M2 500 microamps, W1 by L1 equal to 100 micrometer by 1 micrometer, and W2 by L2 equal to 200 micrometer by 1 micrometer. And assume the parameters of the NMOS transistors are given, and voltage is also given. And for the PMOS transistor, the mu p and COX is given, and VTHP is given. So consider R1 equal to R2 equal to 10 kilo ohm, and VDD equal to 5 volt, and ignore the RDS1 and RDS2. Can you calculate it? At least try, then I will solve. Okay. And from the small signal model, you have to calculate it.
Ma'am, is the option C only, ma'am?
Yes, option C is the right answer. Can you little bit explain how you have calculated?
Ma'am, I have used the formula of ID equals to half mu n Cox by W by L GS minus VTH whole square, ma'am. Using that formula, I have derived the equations into two equal parts, ma'am. G1 and GM1 plus GM2.
Hmm.
So that
Okay, let's see. Sorry. Let's draw the small signal circuit. Sorry. So voltage across this is the VT. This is VT, okay. And this is GM2 and VGS. GM2 into VGS. And this one is GM1 into VGS. So, and this particular positions, like this is plus and this is negative. So this is VGS. This is R1 and this is R2. Okay, so let's calculate the GM1 and GM2. Tell me the equation how to calculate the GM1. Root over twice of ID.
Ma'am, can I?
Yes.
Mu n Cox W by L ID, ma'am.
mu1 twice of ID into mu1 COX.
Of
And all the values are given. Okay, W by L for M1. Tell me the value. GM1. Just put all the value. Okay, the ID value is given, mu and COX is given for NMOS, and W by L for M1 is given. So the value is, I think, 3.316. Okay, and simultaneously calculate the value of GM2. Same, right? This values is 3.162. 62 ms millisecond. Okay, so then from this circuit you have to calculate like IT. IT is GM into VGS GM1 into VGS plus GM2 into VGS plus VT by R1 plus R2. R1 plus R2. Okay. From here we have to calculate the value of VGS. VGS equal to VT into R1Y just voltage divider rule plus R2. Okay, so from here IT is equal to VT into plus GM1 plus GM2. Into R1 plus 1 by R1 plus R2. Okay, from here I'm writing here Vty rt it equal to r1 plus r2 1 plus r1 into gm1 plus gm2. So R output equal to Vty it and this value. Just put all this value like R1, R2 and GM1, GM2. You will get 304. Okay. So I'm moving towards the next question, question number 5. So this is calculate the small signal gain of the given circuit. If ID equal to 2 milliamps, mu1 COX is 100 and VTH is 0.5 at lambda equal to 0. So please try to solve it.
Hello?
Yes.
Ma'am, is the option C only, ma'am?
Yes, option C is the right option. Anyone
Minus
else?
4.
Yes. Manisha? Jasmine? Okay, let's wait for 2 minutes. I want all of you please actively participate on it. Others, please try to solve it. So how to solve it? Like Gm equal to root over twice of id.
Ma'am, excuse me, ma'am.
Yes.
We can solve the ma'am root of u and c of w by l into id, ma'am.
Yes. Gm equal to twice of mu and cx w by l into id. Right?
Yes, ma'am. Yes, ma'am.
I'm writing the same things.
Oh, okay.
Mu and cx w by l. Tell me the value. 4.1.
4.7.
Yes. And AV equal to the gain is minus GMRD, right?
Yes, ma'am. Yes, ma'am. Minus GMR.
So RD value is 1. The value is minus 4.71. And this is in milliamps per volt, right? And this RD is in kilo. So it is cancel out. Minus 4.71. Option C is the right option. So this is question number 6. Given GM1 is 20 ms and VTH is 0.4 volt, calculate the RD for drain current of 1 milliamps.
Ma'am, is the option in 1.3, ma'am?
Yes, 1.3 is the right option. Can you little bit explain how you have solved?
Okay, ma'am. Ma'am, I have taken the ID is equals to half K into GS minus VTH, ma'am. Then GM is equals to delta ID by delta VGS, ma'am.
Okay. See, like what we know, GM equal to twice of ID by VGS minus VTH. VTH is given 0.4 and GM1 is given 20
Yes,
ms.
20.
ID is 1 milliamps is given. So from the equation, can we write like GM value is given, right? So it
GM
is,
is given, ma'am. GM is 20 and ID is 1 milliamp.
yes, it's 2 into 1 milliamps, okay, by VGS minus VTH. So you have to find out the value of VGS minus VTH. Tell me the value of VGS minus VTH.
Ma'am, 0.1, ma'am.
Yes, 0.1. So what is the value of VGS?
0.5, ma'am. Then VGS is equal to
0.5.
0.5.
Yes, 0.5. 0.5. So now here you can see from the circuit the VDS equal to VGS. Is this right? You have take we have to take the VDS equal to the VGS equal to VDD minus
Ma'am,
IDRD.
excuse me. Ma'am,
Yes.
ma'am, VDS is equal to VGS plus IDRD. Can we take that formula, no, ma'am?
Just I'm taking the value of this VGS. Here VGS equal to this VDS, okay, and VDS equal to this VDD minus IDRD.
Okay.
IDRD. This both are same. So VDD is 1.8, right? And ID value is 1 milliamps, I think. Yes, 1 milliamps into RD value. RD is given. Yes, RD value you have to find out. And VGS is given 0.5. So from here, RD is 1.3. Sorry, this is RD.
Actually,
Yes,
1.7, ma'am.
1.7 or 1.3.
1.7, ma'am. Then we can add D is equal to 1.8 minus 0.5, ma'am. Then we can divide the formula into 1.8 minus 0.5 by 0.01 by, then we get the answer, ma'am, 1.3.
From here, right? Just calculate from here. 1
Yes.
millions into RD 0.5 and this is 1.8. Now tell me from here the RD value.
RD is 1.3 only, ma'am.
Yes, 1.3,
3,
right?
ma'am. Yes, ma'am.
Yes. The final answer is 1.3. This is the kilo ohm. So I'm moving towards the question number 7. The input impedance of a common drain stage is dash, then of common gate stage. First option, the greater than or smaller than, equal to or half.
Option A, ma'am. Greater than.
Yes, option A is the right option. C. The input to a follower stage is at the gate of the MOSFET. So hence the input impedance of a follower will be much higher than a than of a common gate stage. So next question, the MOSFET can be used to operate an amplifier in cutoff region, linear region, saturation region, or deep triad region.
Ma'am, saturation region, ma'am.
Yes, saturation region. Next question number 9. The MOSFET gate to source capacitance CGS in saturation region can be given as dash neglect overlap capacitances. So find out the right option.
Ma'am, 2 by 3 WLCX.
Yes, 2 by 3 WLCOX. This is the question number 10. A MOSFET biased in common drain configuration is best suited for the designing a dash transconductance amplifier, current buffer, or resistance amplifier or voltage buffer?
Voltage buffer.
Yes, voltage buffer. Good. This is a question number 11. In the saturation region, the small signal voltage gain of a MOSFET amplifier is proportional to only RD, only Vin, and RD and overdrive voltage VGS minus VTH, or option D, threshold voltage.
Ma'am, first option only RD.
You can recheck this answer. Okay, the option is right option is option C, overdrive voltage also. Okay, you can recheck it.
Okay, ma'am.
This is the question number 12. In the triad region, the MOSFET behave primarily as a current source, a resistive element, a voltage source, or a capacitor.
Second option, ma'am. Resistive element.
A resistive element, yes. This is the question 13. For proper amplifier operation with the minimal distortions, the MOSFET must be biased in cutoff, triad, saturation, or subthreshold. So, what is the right option?
Saturation, ma'am.
Saturation. This is the question number 14. The small signal transconductance of a MOSFET is. So, which one is the right option?
Option A, ma'am.
Yes, del ID by del VGS. This is the question number 15. The small signal voltage gain of a MOS amplifier is approximately. So, try to find out the right option. The gain.
Ma'am, second option, ma'am. Minus GMRT.
Minus
Yes.
G.
This is the question number 16. In the hybrid pi small signal model of MOS, the output resistance R0 arises due to threshold voltage variation, channel length modulation, subthreshold conduction, or body effect.
Channel and modulation.
Yes, channel length modulations. The delay of a MOS analog switch is given approximately by. Which one is the right option?
Ma'am, option A, pi R is equal to RC.
No. The right option is option C. You can
0.69.
0.69 into RC. You can recheck it, okay?
Okay, ma'am. Okay.
This is the question number 8. A MOSFET has mu and CUX is given, W by L is given, and VGS minus VTH is given. So find out the GM.
Ma'am, answer is 1 milliseconds, ma'am.
Yes. Tell me how to find out this value of GM.
Ma'am, GM is equal to mu n Cox W by L, VGS minus VTH, ma'am.
Yes, mu and CUX W by L into VGS minus VTH. Please practice this type of question. So GM mu and CUX value is given like 200 microampere. So 200 into 10 to the power minus 6 into 20 W by L, and VGS minus VTH value is 0.25. Okay, so GM value is 1. So this is the question number 19. GM is given, RD is given. So calculate the small signal voltage gain, AV. Tell me how to find out these values, AV.
GM into RD.
Minus GM into RD. Tell me the value. Minus GM into RD. 1 milliamps per volt into 10. So kilo and milli is
2
cancel out.
means
So
gain
the
is 10.
value is minus 10. Okay. So this is the question number 20. A MOS analog switch has a 1 resistance, 1 kilo ohm, and drive a load capacitor C equal to 10 picofarad. Find out the propagation delay. We already discussed this, like delay and the equations. Tell me how to find out this propagation delay.
Ma'am,
Yeah.
TP is equal to R into C, ma'am. R on into C.
R1 into C or
69 into R.
0.69 into R. Yes.
0.69 into R.
0.
0.69 into
Yes. 0.69 into R1 C. Good. So tell me the value. 0.69.
6.9 into 10 power minus 9.
Yes, nanosecond. Into 10 to the power 3 into capacitance is 10 picofarad. 10 into picofarad minus 12. So it is 6.9 nanosecond. So this is the question number 21. So a common source amplifier has GM equal to 2 milliamps per volt, RD given, R0 is given. Find out the small signal voltage gain. AV you have to find out. Tell me what is the equation, how to calculate this AV?
ma'am, minus GM into RD into R
Yes, minus
minus GM
GM
GM into
into RD, capital
RD
RD,
parallel to
R
RD
naught.
parallel to R naught.
R naught. Yes, good. Now tell me the value of this AV. AV equal to minus GM into RD parallel to R0 or R naught. So GM value is given is 2 milliamps, 2 into 10 to the power minus 3. And how to calculate this RT parallel to
0.018.
um, sorry, what is the value?
0.018.
This 100 is in kilo ohm. Okay, let's see. 2 into 10 to the power minus 3 into 10 kilo ohm, like kilo ohm, multiply with 100 kilo ohm. This is in parallel, okay? By 10 kilo ohm plus 100 kilo ohm.
110 kilo.
Yes, 100 kilo ohm. Then the value is minus 2 into 10 to the power minus 3.
2, ma'am. Gain is 2.
Yes, 110. This is 110 kilo. And this is 10 kilo into 100 kilo.
Ma'am, is
100.
the answer minus 18.8, ma'am?
Yes,
8, ma'am?
minus 18.8. See, this kilo cancel out. 10 is cancel out, 10 is cancel out. Then what we are getting from here? Minus, and this is 10, sorry, minus 10 to the minus 3, and this kilo, it is cancel out. So in the upper portion is 10 means 100 into 2 minus 200 by 11, right?
Yes, ma'am. Minus 200.
Yes, by 11, this is minus 18.18. So this is the gain. Okay. So this is the question number 22. For a common gate amplifier, GM is given, RD given. The voltage gain you have to find out.
20, ma'am.
Yes,
Minus 20.
20. Um, it is common gate and is normally the sorry, AV equal to GM into RD. AV equal to GM into RD. This 20. Next question number 23. A CD amplifier is also known as Common source, common gate, source follower, or push pull amplifier?
I'm source follower.
Yes, source follower. Question number 24. The approximate voltage gain of a common drain amplifier is?
Option A, ma'am, or
Uh,
1.
yes, 1. Option C is the right option. Common drain na AV is almost 1, almost nearly equal to 1. For the common gate amplifier, calculate the input resistance if GM equal to 4 milliamps per volt. R in. You have to find out the value of R in.
Ma'am, Rin is equal to 250 ohms.
Yes, 250 ohm. How to find out this? R in equal to
Ma'am,
1 by GM.
Rin 1 by GM.
Yes, 1 by GM. Good. So it is equal to 1 by 4 into 3, so 250 ohm. So which capacitances are dominant in MOSFET high frequency model?
Ma'am, CGS, CGD.
Yes, option B, right? CGS and
Yes, ma'am.
CGD. Gate to source and gate to drain.
To drain.
For a MOSFET with W equal to 10 micrometer, L is 1 micrometer, and COX is given. Calculate the CGS in triad region. CGS in triad region. Tell me in triad regions what is a
Ma'am,
formula
2
to
by
check for
3, 2 by 3
it?
COX W by L.
It is in triad region. It is not in saturation. Previously, the condition is it is in saturation region. In that time, the capacitance is 2 by 3, right?
Yes, ma'am, 2 by
It,
3.
it is in saturation, it is 2 by 3, and it is in triad or linear or triad region. So in that case, CGS value half of mu l WL COX, because in
Okay.
saturation it is 2 by 3. Okay, when it is CGS, but in triad region it is half of W into L into COX. Okay, so tell me the value. You have to find out the which region. Like in saturation, then it is 2 by 3. If it is in triad region, then half of WLCOX. Half of W 10 into 1 into 5 F farad. It is 25. F farad.
25 picofarad.
Yes. So this is the
25.
question number 28. Why is the cascade topology preferred in high frequency design? To increase the input capacitance, to reduce the GM, or to suppress the Miller effect by reducing the gain at the drain node, or option D, to reduce the threshold voltage?
Ma'am, C to suppress the Miller effect by
Yes,
reducing the gain.
good. Then question number 29. Which amplifier topology is used to minimize the Miller effect? Common source, common follower, cascade, or differential pair?
Cascode, ma'am. C.
Yes, cascade. Option C. This is the question number 30. In a common source amplifier, the effective input capacitance due to Miller effect is C input equal to CGS, or C input equal to CGS plus CGD, or C input equal to CGS plus CGD into 1 plus AV, or C in equal to CGS plus CGD by 1 plus AV.
Ma'am, C in is equal to CGS plus CGD.
Yes, option C is the right option. So here I have today I am taken only this 30 question. So when we will meet next Tuesday, 7 to 9 p.m. Here I am ending the section. Thank you.
Thank you, ma'am.
Thank you.
Okay. Hello, good evening, John. Actually, I have already taken the session. So, if you want to discuss some of the question from previous session, from this session, so we can go through the question. So, actually, the already I have taken. I have said this 30 question. So, do you want to go through some of the MCQ type of question? Like 10 question we can discuss here. Can I? And I will upload this today's session in my YouTube channel. I will share the link, and also I will upload my this PPT on the site. So do you want to go through some of the question here, then I can continue the session again for you, or I will upload, you can see from there also. Hello.
Yes,
Yes.
ma'am.
So can I go through the question, or
No, ma'am. No, ma'am. No, ma'am. No, ma'am. Uh, I will download your videos, ma'am. No problem.
okay, thank you.
Just somewhat I will remember and I will come, ma'am. No problem, ma'am.
Okay, thank you.
Okay, ma'am. Ma'am, is there any group to discuss these questions, ma'am? In WhatsApp group or any group, ma'am?
No, no, I don't think there is any group. I think they have actually selected two TA from the PMRF students, and then the first session I think taken by another TA Friday. I think six
Yes,
to
ma'am.
something.
Yes, ma'am.
Then
Yes,
the
ma'am.
same session here I am discussing on Monday. Sorry, Tuesday 7 to 9. But I am taking some of the like MCQ type of question or
Yes,
numerical
ma'am.
type.
Yes, ma'am. You are taking the MCQ type of
Yes.
questions,
So
ma'am,
it
with explanation.
yes.
But in Saturday, they are taking the only practical, theoretical topic they are taking.
Yes. So
There is
this
no
type,
MCQ question discussion.
yes,
Now
but
you
this
are
type
only the
of,
discussing the MCQ questions.
yes, this
So
type
this
of
is useful for me.
yes,
Yes, but some days. Moreover, the questions are very tough, ma'am. Actually, sir, Sudeep sir taking the PPTs, but in this assignment questions we cannot understand because in this
so directly,
in
see, directly we can discuss the assignment question here. Okay,
okay, yes,
we
ma'am.
can discuss the related type of things, but directly
Yes,
that type of
okay, ma'am.
question we can discuss here, but related type of topic we can discuss here. Okay.
Okay, ma'am. But I have a doubt in the question number third and fourth, ma'am. In week six, question number third and fourth. Actually, there is showing the MOSFET inverter. So, how I calculate the small signal input resistance value, ma'am?
Okay, so you can directly mail this, but if the assignment is submitted and date is over, on that case, you can directly mail the question. Okay, but before submitting the assignment, I can't directly help you. This is the
Okay,
problem.
okay, ma'am.
Before
Okay, ma'am.
submitting the assignment, I can't help in the directly that type of question. But
Okay,
I
ma'am.
can
Actually,
like
ma'am.
discuss the same related type of things. But if you are
Okay, ma'am.
facing
Okay,
some
ma'am.
issue, the related type of example I will put here. Okay, so
Okay,
just
ma'am.
directly mail me, ma'am. That I am not understanding, but I will check if it is in the assignment. Then I will not take the direct the question from there. It is an instruction from
Ma'am,
us for us.
mail ID, ma'am.
The type of question I will discuss. Okay, so you
Okay,
can
ma'am.
make.
Mail where I can get the mail ID, ma'am.
Yes, I'm giving it. This was .5 at the rate iitj.ac.in. This is my mail ID.
Okay, ma'am.
But I will not discuss the same question.
Okay, ma'am. Okay, ma'am.
Okay.
Actually, I have a doubt for the third and fourth question. Actually, you are okay now, no problem. But I am asking which book I was refer, I'm going to refer. Actually, in slides, I can't answer that questions, but where I can refer this type of questions, if you gave any book references or if you gave like the fundamentals of microelectronics book or any book references means I will refer.
Okay, I will see some of the good books and I will tell in the next class. Okay.
Okay, okay,
Or
ma'am.
if you can mail me, then I will reply on the mail also. Thank you.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
Okay.
Thank you, ma'am. Thank you, ma'am.
Okay.
Thank
Bye.
you. Thank you. Thank you, ma'am. Shall I leave, ma'am?
Okay. Okay. You can leave.
Thank you, ma'am. Thank you.